So welcome to everyone. This is the lecture series of Civil Engineering Short Note. First of all, in the Civil Engineering, there are 13 subjects we are having for competitive examination. Those are, the first one is strength of materials, and second one is structural analysis, and the third one is steel structures, fourth one is reinforced cement concrete structures, fifth one is geotechnical engineering, and the sixth one is environmental engineering, and the seventh one is transportation engineering, and eighth one is irrigation, ninth one is hydrology, 10th one is fluid mechanics and hydraulics, and the 11th one is we are having surveying, and the 12th one is we are having engineering mechanics, and the 13th one is construction materials and project management. So such that you are having 13 subject. So the initiative of this course is only the short note of these 13 subjects for the competitive examination. So once you study this short note, or once you refer our initiative, then you will get an idea to write GATE, ESC, and SSC, JE, and all state government exam. The state government exams, particularly in Tamil Nadu, TNPSC, TRB, TNEB, TANCET, okay, so on and so forth. Okay, so today I am going to teach the short note of RCC structure. This is the first series. Okay, I am taking a reinforced cement concrete structure. A reinforced cement concrete structure is the subject. Okay, that's the first one. I have segregated this reinforced concrete structure as per the short note concern. These are different topics. The first topic is basics of concrete technology. basics of concrete technology, and the second one is basics of working stress method. Third one is basics of limit state method, and the fourth one is shear, bond, torsion, and anchorage. And the fifth one is design of slabs. Sixth one is column. Sixth one is column. One minute. Column. And the seventh one is footings. Eighth one is pre-stressed concrete structures, and the ninth one is yield line theory, and the 10th one is water tank, 11th one is retaining wall. Okay, so like that, so I have segregated around 11 topics. Okay, now we will see the 11 topics short note lecture series. Okay, in the today's class, in the first class, I will teach the basics of concrete technology. Okay, that's the first thing. Now see, the first one is basics of concrete technology. Okay, further this basics of concrete technology, I have segregated some topics. First one is the introduction, and the second one is a characteristic strength, characteristics strength of concrete. Third one is stress versus strain diagram of concrete, stress versus strain diagram of concrete. Next one is tensile. We can say this is the properties of concrete. Properties of concrete. Fifth one is tests on fresh concrete, and the sixth one is test on hardened concrete, and the seventh one is exposure condition, and last one is mix design procedure. So here I have segregated the concrete technology It's of around 8 topics. Okay, and I will teach you only the short notes. Okay, now see the first, the introduction about the concrete. Okay, the first topic is introduction about concrete. Introduction about concrete. So generally, the grades of concrete is denoted as follows. So how we are denoting the concrete? So we will denote the concrete M10, M15, M20, M25, M30. Okay. Out of this, the M10 is the mixed ratio is 1:3:6. M15 mixed ratio is 1:2:4. The same M50 mixed ratio for M30 also. Okay, 1:2:4. For M20 the mixed ratio is 1:1.5:3. For M25 concrete the mixed ratio is 1:1:2. And you know, the thing is, up to M20 concrete, nominal mix design is used. For these three, we will use the nominal mix design. Okay, nominal mix design we will use. For these two or more than M25, we will use mix design procedure as per IS code 10262. Okay, as per this code we will do the process. Now say in this M10, M15, M20, M25, M30, in that this 10, the numeral value, this all numeral values which it says characteristics, compressive, characteristics compressive strength of concrete after 28 days curing. Okay, after 28 days curing. Characteristic cube compressive strength. In India we will use a cube, but in the USA we will use, that is in the USA people will use cylinder. Okay, the next one is in the this one, the M represents the mix ratio. Okay, that is mix ratio. M10 means M means mix ratio. For 1:3:6 mix ratio, you will get a characteristic compressive cube compressive strength of 10. Okay, so this is the thing, but the IS 456 2000 note IS 456 2000 classified the concrete. Okay, 256 classified the concrete as, first one is ordinary, classified as first one is ordinary, ordinary concrete, that is M10 to M20, and the next one is standard concrete. Standard concrete, this will be M25 to M55. Next one is high strength concrete. High strength concrete, M60 to M80. And new code. Now this strength is amended, and it is varies up to 100 M100. Okay, so this is the thing. Now see, next point under the introduction, to find FCK. Actually, FCK is the symbol of characteristic compressive strength. FCK means characteristics cube compressive strength of concrete. Okay, to find FCK, we take 3 cubes. Okay, 3 cubes, that means specimens. Okay, specimens, 3 specimens is equal to 1 sample. We will take 1 sample as per the code. We will take 1 sample. 1 sample is equal to 3 cubes. Okay, so that means 1 sample, which is equal to cube 1 plus cube, next cube. Okay, 3 cubes, second cube, and third cube, and this is X, Y, and Z. So we can take it as, okay, for a sample we will take 3 cubes in order to find out FCK. Okay, now compressive strength of sample, compressive strength of sample, be careful, is equal to average of specimen strength, X plus Y plus Z divided by 2. That is a sample. So if we take the 3 cubes and the cubes having the different strength, in order to find out the sample strength, we have to add these 3 strength, so that we will get a sample strength, not a specimen strength, sample strength. Okay, now the code says, note, the code says, this is also important examination question. Note, code says, as per IS 456 2000, as per IS 456 2000, minimum 3 specimens have to be used to calculate FCK, and individual specimen strength, individual specimen strength shall not fall beyond plus or minus 15%, very very important data, of compressive strength, of compressive strength of sample. That means x plus y plus z divided by 3. Okay, actually this also 3, not 2. Okay, this is actually 3. Average is 3, right? This shall be 3. Okay, what is the meaning? What is the meaning? This, the code says, okay, for example, the cube strength is, okay, the average of this strength, the sample strength is, for example, 100. For example, okay, you got, after adding these 3, you got 100. Okay, that means you can take it, this is 80 and this is 120, this is 100. Okay, then the sample strength is what? 80 plus 120 plus 100 divided by 3, which is equal to 100. This is the sample strength. And code says the individual strength should not fall beyond plus or minus 15% of the compressive strength of the sample. So that means the individual strength should be around 85% of sample strength. It can maybe more than 15% of the sample strength or less than the 15% of sample strength. We can say this is 15% of sample strength. So the value should not be more than that. Meaning, so the limit is this one. This is 85%. Another one is 15%. The value which lies above and below is unacceptable by the code. Okay, by the code. Now we can check whether the first cube is acceptable or not, and like that second and third cube. For example, what is 85% of 100? 85. So 85 is the answer. You should get 85, but here you are having a less than 80, right? So less than 85, therefore this is unacceptable. This next one is this one, 115 1.5 into 100, and this shall be 115, not more than this 115, but this is unacceptable because it's more than 120, right? More than 120. Okay, now this is 100. Yes, this is acceptable because this is in between 85% to 115%. So if we calculate it, this is 85 kPa and this is 115 kPa. So only 100, the third cube is acceptable, which is set by code. Okay, now next important point is the cube has to be cured at an temperature of 27 degrees plus or minus 2 degrees Celsius. Okay, 2 degrees Celsius, 27 degree plus or minus 2 degrees Celsius with an relative humidity of 90%, with an relative humidity of 90%. So this is very, very, very important. The data is important. So there is a question, the temperature of curing and the humidity. Okay, the next point is generally cube strength generally cube strength has to be determined for 7 days and 28 days curing. After 7 days curing and 28 days curing. So this is also important. For 7 days curing, we will get a 70 percentage strength, that is 70 percentage of FCK. The cube will attain the 70 percentage of ultimate strength. And this one, after 28 days of curing, 99 percentage of FCK it will be obtained. These two are also a question. Okay, so this is about basics. Now see, introduction, what is a grade of concrete? But as per IS 456 classification also we having seen. Then what is the codal condition? Minimum 3 cubes we have to take for test sample. 3 cubes is equal to 1 sample, and the tested value should not fall plus or minus 15 percentage of the sample strength. Okay, the individual strength is should not fall beyond 15 percentage of plus or minus the sample strength. And this is the curing temperature and humidity, and the cube will be tested for 7 days and 28 days, and for their strength is 70 percentage of FCK. After 7 days, after 28 days, 99 percentage of FCK. So that's the thing. So the first introduction will be over. The next part is we have segregated the compressive strength. Compressive strength. What is this? So what is a compressive strength? Compressive strength means compressive strength means, you know, capacity of cube or cylinder. Okay, cylinder or prism. Generally we will use these three. Okay, prism, capacity of cube, cylinder, prism determined by applying axial force. So there is a cube. The cube will be tested by applying compressive force. Okay, and the before failure from the stress strain curve, you can able to find out the what is the maximum compressive strength of the cube. Okay, generally this is the compressive strength. The next point is what is the characteristic compressive strength of cube. This is a general definition. Now we are going to write characteristics compressive strength of cube. Be careful. This is the general compressive strength. Now characteristic compressive strength of cube, which is denoted by a symbol FCK. Okay, what is the meaning of characteristic compressive strength? Meaning it is the strength. Characteristic compressive strength means it is the strength. It is the strength below which not more than 5% of the test results are expected to fall. Expected to fall. What is the meaning? Characteristic compressive strength means it is a strength below which not more than 5% of test results are expected to fall. Okay, for example, we tested 100 cubes. Let us take 100 cubes. We tested a cubes, 100 cubes, 100 cubes, etc. So this is the 100th cube. 1, 2, 3. Out of this 100th cube, 95% of test results should be positive. That means our required strength. 95% number should get our required strength. Required strength. 5 cubes can be allowed. That means 5 cube, the strength of the 5 cube can be less than the required strength. It is possible, allowed. Okay, 5% error is allowed, but 95% of strength should be required. Okay, but the problem is, in order to achieve 95% of confidence limit for 3 cubes. See, for 100 cubes, 95 cubes should have required strength. 5 cubes shall go less than it is allowed, less than the required strength. But we know that as per IRC, minimum how many cubes are required to test? Only 3 cubes. Okay, for 3 cubes, see, if we use a 3 cubes, what is a 95% of 3 cubes? Around 2.8. Around 2.8. Then it is somewhat 2.8 is a decimal number. There is no cube 2.8 number, right? And what is the acceptable failure value? 0.2. 0.2 is acceptable. It can be less than the required strength. But 2.8 number of cubes should have the acceptable or the required strength. But the problem is the number is in decimal. So there is a problem now. In order to perform the 95% of confidence limit, so that the IRC to get 95% of confidence limits for these 3 cubes, IS 456 2000 defined a strength called target mean strength. Okay, that is FT. Now FT is equal to FCK plus KS. FCK plus KS. That means if you required a characteristic strength of a cube is 20, then your target mean strength is somewhat more than, for example, 23. If you design these 3 cubes for 23, then the meaning is then you can able to achieve the 95% of confidence limits. Okay, 95% of confidence limits. That means you can able to achieve the 20% or 20 Newton per millimeter square of FCK. That is a IS 456 says. If you design 23, the cube is designed as a 23 Newton per millimeter square, then we can able to achieve at least 20 Newton per millimeter square characteristic compressive strength. That is a meaning. Okay, so if you design 23 Newton per millimeter square, then only at least we will get a 95% of, I am saying this is the example, okay, 95% confident limit of our characteristic compressive strength. Okay, meaning suppose you want FCK. In order to get FCK, you have to target somewhat more. Then the target is the function of K into sigma. Okay, K into sigma. Now, what is K and what is sigma? See, the K is equal to acceptable, expected to fail, expected to fail, and the value K. So the K value, it is depends upon the percentage of expected failures. As per IS 456, we have to allow only 5% of failure. For 5% of failure, then what is a K? Then next one is for 50% of failure, then what is the K? The next one is for 0% of failure, there is no failure. No failure. Okay? No. Everything is fair, 100%. Okay? Everything is gets failed. Everything is gets failed. Now, K is equal to, for 5%, 1.65. For 50%, K is equal to 0. And this one, for 0%, is infinity. K is infinity. What is the meaning of this? This was taken from the normal distribution curve. For 5% test result, okay, if we take now this case, this is the mean value, and the 5% of test result can be allowed, and this is the 5% of test result. This is the K value 1.65 for 5%, and this is, these two are 5% results are can be allowed, and the remaining all strength will be lies in between this dumbbell shape. Okay, similarly 50%, suppose 50% failure, expected failure is happen, then in that curve there is no K. What is the meaning of 50%? It lies on the this failure, everything is failed, everything is failed, therefore there is no K. K is equal to 0. For no failure, expected failure, then such kind is not there. K is equal to infinity. Okay, what is the meaning? No failure. So that means this is the curve. So it will go asymptotically. It will go on. So zero failure means it will go on. Therefore, this is the mean value, and K is always measured from center. It will go up to infinity. We don't know where it is. K is equal to infinity. Okay. So this is about K. Now you understood what is a K. Now what is sigma? Actually this I should put a sigma. Okay. Now sigma, the concept of sigma. Okay, sigma, it is depends upon quality of concrete. So it is depends upon the quality of concrete. Therefore, if you plot the values, okay, this is sigma, this is the grade of concrete. grade of concrete: M10, M15, M20, M25, greater than M25. So for M10 and M15, the value of sigma is 3.5. M20 and M25, the value is equal to 4. Then M greater than 25, then this value is 5. Okay. And here one point we need to understand, the sigma is the function of quality of concrete. Quality of concrete, not quantity of concrete. Okay, so this is the thing. Now acceptance criteria of this strength. Acceptance criteria as per IS 456 2000. Here the first one is individual strength. Individual strength of the cube. Individual strength of cube which is greater than or is equal to, shall be greater than or is equal to FCK minus 3. Okay, and it is applicable only up to a strength of, up to a grade of up to M15, up to M15. Next one is the individual strength of the cube, strength of cube greater than or is equal to FCK minus 4. The cube which is greater than or is equal to, the grade greater than or is equal to M20. Okay, the grade which is greater than or is equal to M20. M20. This is about the individual strength. Now, average strength of all cubes. Average strength of all cubes. Average strength of cubes shall be greater than or is equal to maximum of FCK plus 0.825 sigma and FCK plus 3. This is up to, same as this, up to M15. But the next one is average strength of cubes greater than or is equal to, which is the maximum of FCK plus 0.825 sigma and FCK plus 4. And this value also up to greater than or is equal to M20. Okay, and the next point under the compressive strength, note, the point is this: analysis of target mean strength. Analysis of target mean strength is done based on normal distribution curve. Okay, by using normal distribution curve, we will test okay, or we will analyze the cube strength. This is the normal distribution curve, okay. In that, the center point is a mean. This is one normal distribution curve, and the next curve, for example, there's another one curve we can take, and one more curve, one more curve. Yes, this. Okay, this curve, the sharpened curve, is very good, very good, okay. And this one, the second curve, is good, but the third curve is, this one is average. So if the curve is sharpen and sharpen, then you will get an efficient result, okay, the efficient cube result that we will get, okay. Now the next point under this compressive strength is, so we having seen this is characteristic compressive strength of cube. Now characteristic compressive strength, compressive strength, what is the meaning of this characteristic compressive strength? See, in lab, what we did in lab, we did the experiment on cube, but the cube size, we give a concentrated force P, and the size of the cube is 150 mm by 150 mm by 150 mm. So it has a cubical size and the concentrated load that we applied. But in practical, the structural elements are different shape, okay. In practical, structural elements like beam, column, okay, slab, etc., okay, are subjected to or having different shapes and different loading conditions. Here is a concentrated load, but the slab may be subject to some other load. Beam is subjected to UDL, UVL, so on and so forth, right? Therefore, there is a effect. Therefore, there is a effect on, in practical. Therefore, in practical, there is a shape correction. There is a shape correction. There is a shape correction and load correction and loading correction shall be applied in order to get actual FCK. Actual FCK. So the lab strength is FCK. The lab strength is FCK. Okay. But actual FCK is not the lab FCK. Therefore, the FCK will be reduced into FCK divided by a reduction factor. So this is the reduction factor. A reduction factor to consider is a reduction factor to consider shape effect and loading effect. Loading effect, and it will give 0.67 FCK. So this is not a partial factor safety. Okay, this is not a factor safety. This is the reduction factor. Okay, so in actual, that is in lab, we will use this FCK. In practical, we will use the characteristic compressive strength is 0.67 FCK. In lab, the characteristic compressive strength is FCK. In practical, we will use 0.67 FCK. Okay, so that's the thing. Now, generally, the next point under this compressive strength is we will use in order to find compressive strength calculation, we will use cube. Okay, what we can use cube, cylinder and prism. But generally in India, we will use cube. Okay, cube. Now see, but cylinder will be used in USA. Okay, then the comparison between cylinder strength and cube strength. Comparison between cube strength and cylinder strength. There is a comparison. Okay, so this is also very important examination question. So generally, cube strength, which is equal to 1.25 times this cylinder strength, or you can say cylinder strength is equal to, or you can say cylinder strength, which is equal to 0.8 times the cube strength. 0.8 times the cube strength. Okay, why it is happen? Why this strength variation? Why this strength variation? Why this strength variation? The reason is cylinder has high slenderness ratio. as compared to cube. You know the cylinder having the dimensions of 150 by 300. The diameter is 150 mm, but the length is 300 mm. But in the cube, all sides are 150 by 150 by 150 mm. Okay, this is the cube. Understood? Now, note under this, the cylinder that is compressive strength obtained from cylinder, we can write from cylinder is more reliable than cube. Why? Because why is more reliable? Since the effect of friction on the cube is more than cylinder. Okay, so if you look the diagram, this is the cylinder. You know that during test time there was a plate we will keep at the top and bottom. This is the plate at the top and bottom, and this is the machine which is giving the load. Now because of this machine and plate, there is a frictional force. The friction, okay, the effect of friction will be at certain depth at the top and bottom, and this effect is distributes this fashion. The friction force will be distribute something like that, and from here also the friction force distributes something like that. So this is the frictional effect or affected by friction. Okay, this portion affected by friction, and this also, but this portion is a free from friction, effect of friction. That's why this is the free from friction, so we can able to understand exactly what is the strength of the concrete. But if you see the cube compressive strength is this one. This is the plate. Above and below we will keep a plate and giving a compressive force from top and bottom, so that the effect of friction will be acts. This is the effect of friction. Okay, effect of friction. So throughout the depth, the cube is affected due to the friction between machine and plate. The friction between machine and plate, which is affected throughout the length of the cube, but in the cylinder, throughout the length is the friction is not affected. Okay, So this is the region affected by friction. It's a region affected by friction. This is the reason. This is the reason the compressive strength which is obtained from cylinder is more reliable than cube. This is the cylinder and this is the cube. I hope you understood. So we having seen the second chapter, the second part. See the compressive strength. What is what? So we have written everything. Okay. The summary of this is there are three compressive strength I have written. First is a compressive strength, simply compressive strength. First one I have written simply compressive strength. Second, I have said compressive characteristics compressive strength. Characteristics cube compressive strength. Next one is characteristics compressive strength. What is the difference? So compressive strength is a generic term. Compressive strength is a strength against compressive load. You know, right? It is a strength against compressive load. Characteristic compressive strength means it is defined by IS 456 FCK. That is strength of the cube as per IS 456. Characteristic compressive strength, this is not a cube. Characteristic compressive strength means the strength which we are taking for a slab, beam, so on and so forth. For design, we will consider 0.67 FCK. That is, after reducing this FCK by a factor 1.5, we will get 0.67 FCK. So this is the summary, because three words maybe confuse you. One is a compressive strength, another is a characteristic cube compressive strength, another one is a characteristic compressive strength. Okay, and the third one is what we have segregated the entire concrete technology into around 8 parts. Stress strain diagram of concrete. Okay, stress strain diagram of concrete that we are going to see. Stress versus strain diagram of concrete. Stress versus strain diagram of concrete. Okay, if you draw the stress versus strain diagram of concrete, the diagram looks something like that. Okay, this is the diagram. See, we will get one diagram something like that, and another one diagram that we will get something like that, and one more diagram that we will get okay is something like that. And this is the value for M30. For example, the next one is M35. The next one is, we can take, this is M50. You know, the stress strain, all values, all concrete grade attains the ultimate strength at a strain of 0.002, and the remaining the remaining, this is 0.004 and the last one is 0.006. This is thing. And up to the ultimate strain, that means strain corresponding to the ultimate stress, the test is controlled by, or the test is done by, or this graph, okay, left side of this 0.002, the graph is obtained by controlled stress method. But the right side of this strain, 0.002 strain, which is obtained by controlled strain diagram. Controlled strain method. Okay, this is stress, this is strain. And some of the important points that we can write. The stress versus strain diagram is non-linear. See the graph? Non-linear. Is non-linear, but at the starting portion, okay, starting portion, stress versus strain diagram is linear. Means at low stress value, the stress somewhere here. For example, the stress at this point, the strain is, okay, for low stress values, the graph will be linear. Okay, at low stresses, stress versus strain diagram is linear. That's a point. And the next point, all grades of concrete attains ultimate stress. At a strain of 0.002. All grades of concrete, see M30, M35, M50, so on and so forth. All grade of concrete attains the maximum stress of 0.002 strain, and all other grades fails a strain between between 0.004 to 0.006. Okay, these are the important point that we have taken from stress versus strain. Now, next we are going to see fourth one is, what is the fourth one? We can see this syllabus. We have segregator. It's a property of concrete, right? The fourth one is properties of concrete. So the properties of concrete I have segregated as follows. A, compressive strength. It is denoted by FCK. This already we having seen. Next one is tensile strength. Okay, it is a tensile strength. And third one is creep of concrete. And D, shrinkage of concrete. Shrinkage of concrete. And F, modulus of elasticity of concrete. Modulus of elasticity of concrete. Okay, A, B, C, D. Actually, this is E. F, fatigue. Okay, fatigue. So around 6 properties we are going to see one by one. So this compressive strength of concrete we already seen. Done. Okay, next one is tensile strength. We are going to see tensile strength. B, tensile strength of concrete. Tensile strength of concrete. See, tensile strength of concrete is tensile strength of concrete is approximately 10% of compressive strength of concrete. Approximately 10%, okay, but it will be vary 7% to 15%. It will be vary around 7% to 15%, so approximately 10%. Okay. Now, it can be done by flexural tensile test. Okay, there are 3 types of strength. 3 types of tensile strength. 3 types of tensile strength. One is flexural tensile strength. Flexural tensile strength is denoted by a symbol FCR. FCR, which is equal to 0.7 root of FCK as per IS 456 2000. Okay, this is the one formula. Another is this also practically determined by using the 3-point load 1. So from this test we will obtain the flexural strength of the concrete. From this 3-point loading case, this is the constant load that the third point load will be applied on the beam till it reaches the first crack. From that we can use this formula M by I is equal to F by Y is equal to E by R. By using this formula you can able to calculate flexural strength of the concrete practically, but IS 456 given this one. Next one is split tensile strength. split tensile strength. Split tensile strength, which is represented S F split. Okay, F split is approximately, we are having 0.66 FCR. That is the previous one, FCR. And practically, it was determined by using the cylinder test, determined by split cylinder test. Split cylinder test. This is the cylinder. Okay, this is the center point, and the load will be acts on the line load, which is acts along the length of the cylinder, and because of this load, it will split along the length. Okay, so it will split something like that and becomes as a two parts. Okay, now the strength corresponding to this transfer direction, that is a split tensile strength. Because of this load, the cylinder split into two halves in the longitudinal direction. Okay, therefore in the longitudinal direction, if it is split, then there is a split tensile strength will be measured. Okay, this is practically, but 0.6 is FCK, FCR is the code. Next one is direct tensile strength. Direct tensile strength. Suppose this is the member. Here we will give the force in the direct manner. Okay, direct shear strength, you can write is F direct tensile strength. Therefore, F dt, which is equal to 0.5 to 0.63 FCR. You know what is FCR? Is a flexural tensile strength. Okay, the direct tensile strength means here we will apply a load. For example, this is the Q. Direct load we will apply in order to measure this tensile strength. Okay, now see, the values are very important. Here note, important point, that is note FCK always greater than FCR, always greater than, you can look it, then F split greater than always F direct tensile strength. So this also important examination portion. Now we having seen the tensile strength of the concrete. Okay, so tensile strength of the concrete. So next one is, I think, creep, right? See, creep of concrete. We are going to see creep of concrete. First of all, what is a creep? Creep is a large plastic strain. Creep is a large plastic strain. Large plastic strain under constant loading. Under constant loading. That is a creep. Okay, and it is due to, creep is due to readjustment of micro cracks and gel water. So creep is a large plastic strain under constant loading. Also the creep is occur due to readjustment of micro cracks and gel water. Okay, now at the initial stage, the creep is at the initial stage, creep is so high. Creep is so high so that delaying the floor finishes. The word is important. Floor finishes. This is somewhat application oriented thing. So delaying the floor finishes at a initial stage. At the initial stage, in order to reduce the strain, in order to reduce the creep strain. See what this is. Actually, the creep at the initial stage, creep is so large. So in the initial stage, if you allow the load, then the strain again gets increased. So that's why initial stage creep. So initial stage, the creep is large. In that time, you should not allow the floor finishes. The floor finishes will be allowed after the initial stage. Okay. So if you apply the floor finishes after the initial stage, then the creep will be reduced. Otherwise, the creep will be more. The next one is creep coefficient. Creep coefficient theta, which is equal to ultimate creep strain divided by elastic creep strain. Elastic creep strain. If you plot the stress versus strain, if you plot the stress versus creep strain, this is the stress, this is the strain, then the graph will go something like that. Okay, and somewhere here this portion, and this is the left side, this is elastic strain, and this side is elastic strain, and the right portion is a plastic strain. It's a plastic strain, or you can say creep strain. We defined creep is a large plastic strain, right? Now see, if you plot the graph between, if you plot the graph between time as well as strain, this is strain E as well as time, then this is the elastic strain. After that, the creep gradually increases and it reaches the certain level. That point is the ultimate creep strain. Once it reaches the ultimate creep strain, then this ultimate creep strain still be constant and it is go on for time being. Okay, so this is ultimate. We can write this point is ultimate creep strain, but this point is elastic or instantaneous. Instantaneous creep strain. Instantaneous creep strain. Okay, now see here the creep value is more at the initial stage. The value is important. Creep strain is denoted by a theta. Therefore theta and age. Okay, creep strain as well as age. This is important for your examination. The first one is, what is a creep strain? For 7 days, the creep strain is very high, 2.2. So that's why we have to allow the floor finishes, okay, after some days. But initial stage, the creep strain is more. In that time, if you allow the load, then the ultimate strain is so huge. Okay, after 28 days, 1.6. After 1 year, 365 days, this is 1.1. Okay, so this is about all about the creep. Next one is D. Under D, this is creep, right? Next one is a shrinkage. I think shrinkage, right? 1 minute. Yeah, shrinkage of concrete. D, shrinkage of concrete. So the shrinkage of concrete. Shrinkage strain is due to evaporation of water from concrete. Due to this, the shrinkage strain is coming. The shrinkage strain is equal to 0.0003 as per IS 456 2000 is a very important data. Okay, now note, we can write here note is the first point, creep and shrinkage increases with the increase in water content, cement content, temperature, and air entrainment. Okay, the second note point is creep and shrinkage reduces with increase in age of loading, age of concrete at the time of loading. Relative humidity and volume to surface area, which is also called a specific surface area. SSA means what? Specific surface area. So this also you have to keep in mind. These are not the examination question. Now, note number 1, 2. Okay. Next one is E. Young's modulus of concrete. Next property, Young's modulus of concrete. Young's modulus of concrete, this is written as EC. Okay, so the Young's modulus of concrete, there are, okay, actually not a Young's modulus, let us write modulus of concrete. There are three types of modulus. Okay, modulus of concrete, modulus of concrete. Okay, E. So see, generally there are three types of modulus. This is the stress strain curve. Let us take the stress strain curve. The stress strain curve of concrete is something like that. And the different modulus that we are having, the first modulus is initial tangent modulus. Initial tangent modulus, it is also called it as dynamic modulus. It's a dynamic modulus. Okay, it is defined as the slope of tangent drawn from the origin of the graph. It is defined as the slope which is drawn origin of the graph. So this is the origin point. If you draw a tangent from the origin, then it will go something like that. Then it will go something like that. This is initial tangent modulus, or you can say dynamic modulus. This theta, okay, this theta is the initial tangent modulus, okay, and it can be used where we will use this modulus can be used for dynamic loads acts on structure. This modulus can be used when the dynamic loads acts on the structure. That's the first one. The second one is secant modulus, or in right bracket we can write static modulus. Static modulus. Okay, IS 456 2000 defined Young's modulus. This is the important examination question. Defined Young's modulus based on secant modulus. This is the question. IS 456 defined the Young's modulus based on secant modulus, not tangent modulus, not initial tangent modulus. Okay, so only it is based on the secant modulus. Understood? Now it is used when when the structure subjected to static load. Static load. Okay, it is defined as, how can we define? Defined as the slope between tangent drawn to the origin, tangent drawn to the origin, and the point where 1/3 of ultimate stress. So the is a slope between tangent drawn to the elastic curve at the origin, at somewhere here, this point, and the tangent drawn somewhere here at a value of 1/3 of FCK. Actually, this is FCK, for example, ultimate strength. FCK, then for 1/3 of FCK, the tangent drawn to the 1/3 of FCK and the origin. The slope between these 2 points is secant modulus. Okay. Now, as per IS 456, as per IS 456 2000, as per IS 456 2000, Young's modulus of concrete, short term 5000 root of FCK. Also, Young's modulus for concrete for long term, that is Young's modulus of concrete at the short term divided by 1 plus theta. Okay, so this is the formula, very very important. What is theta? Creep coefficient. Okay, and finally this formula we can write 5000 root of FCK divided by 1 plus theta. Okay, now the third modulus. Okay, I can take this is the second one, this is the third one. Okay, first one I can make it here. Last one is a tangent modulus. Tangent modulus. Tangent modulus, it is defined as the slope of, okay, slope of tangent drawn at any point, tangent drawn at any point on stress versus strain diagram, on stress versus strain diagram, and it is used in incremental loading case. It is used in incremental load analysis. Incremental load analysis. So tangent modulus means this will be changed for each and every time, depends upon the load increment, maybe this one, or if the load is increased, maybe this one is a tangent modulus for particular load increment. Okay, so that's the thing. Initial tangent modulus used for incremental load, initial tangent modulus which is used for dynamical load, secant modulus is which is used for static load. Okay, now this is all about that modulus of the concrete, very very important this. Okay, sorry, the next one is we are going to see what is the next one. Static. right? Modulus of then E F. The last one is F. Fatigue. What is the fatigue? We are going to see this. Fatigue is the property of concrete. It is a property. It is a property of concrete by which resistance against cyclic loading. So this point is important. Against cyclic loading. Against cyclic loading. Okay. And next important point is endurance limit. Endurance limit. So this also important point. This fatigue is designed based on this endurance limit. Endurance limit. Endurance limit is the number of cycles which is required to make the test. So endurance limit is defined as it is a limit at which cyclic, okay, it is a cycle. It is a limit at which the concrete has high probability of no failure. High probability of no failure. Now the graph between, if you draw the graph between cycles, number of cycles that we are giving the load, and the strength gradually reduces, and at a certain time at a certain point it reaches to the constant, and the constant, for this constant, to reach this constant, how much cycle which is required to reach this constant stress, we need 2 into 10 raised to 6 cycles. Okay, so this much cycle is required. This is the standard, and this limit is called as the endurance limit, and this acts as the strength. And corresponding to this cycle, the strength we obtained is called as a fatigue strength. This is the fatigue strength. This is the endurance limit cycle. Endurance limit, it is the limit. So this question they will ask you, what is the endurance limit of a concrete? 2 into 10 raised to 6 cycle. So keep in your mind this one, okay, or 2 million cycle. Okay, now we having seen now the properties of concrete. So properties of concrete is over. Next we are going to see what properties of concrete. Next, test on fresh concrete. I think this is under chapter main segregation. This is our segregation, right? Under concrete technology, test on fresh concrete, test on hardened concrete, exposure condition, mixed design. Okay, fifth one, test on fresh concrete. Fifth one, test on fresh concrete. So what are the tests on fresh concrete? So we are having a number of tests for a fresh concrete. Okay, so the first one is slum test, and the second one is compacting factor test, and the third one is VB test. Okay, workability test is performed workability test that performed workability test is performed on fresh concrete. Fresh concrete, or we can say green concrete. Green concrete. Why? In order to, what is the workability? Easiness to work means easiness to work. Okay. And the types of workability test. Types of tests. The first test is slump cone test. Okay. First one is a slump cone test. Here you need to keep in your mind the size of the slump cone. And the size of the slump cone is, so this is 200 millimeter. This is the question. This is top is 100 millimeter and the height is 300 millimeter. Okay. And next one is, second test is compacting factor test. These are the match the following, and somewhere they will ask you. In the compacting factor test, the limited value under this compacting factor test is 0.75 to 0.8. Okay, this value is compacting factor value is 0.75 to 0.8. Okay, but theoretically this is the practical value. Theoretically it reaches up to 1. This value, these are the examination questions, that's why I have written. Third one is VB test. VB test. VB test. Here the time will be measured. Time will be measured in terms of seconds. Okay, if the time is, that is a workability, based on this workability is directly proportional to 1 by VB time. If the time is less, that means if the time is more, then the workability is less. Okay, workability is less. If the time required for see, the test is something like that. I hope you can able to read the test. So initially this is the VB timetable. Over that, first of all, the sample is kept by using the slump cone. After that, by keeping and doing all initial process, the slump cone is take out, and by using motor arrangement we will give the vibration. Due to this vibration, the slump cone changes, it falls down and it comes like a shape. Right? Okay, it's like a circular shape. The time to reach this circular shape with the equal radius from center is VB time. Okay, that VB time, if the workability is very high, then the VB time is very less. If the VB time is very less, the workability is more. VB time is more, then this cone changes into this circle, takes more time because of workability. Okay, so this is the test. Okay, now see, Workability is directly proportional to 1 by VB time. So these are the important points that you have to keep in your mind. Now, what we are going to see, we are going to see the tabular column of this. So that is important for your examination. Okay, for the test procedure and all, for competitive examination is not important. What is the thing? Tabular column. Degree of workability. Degree of workability. Usage. Then slump value. Compacting factor. Next VB time. VB time. Okay. So we can make a tabular column. And this tabular column is important for your competitive examination perspective. Okay. So just to go through this tabular column. Okay. VB time is a compacting factor value and the slump value. That means slump value. Okay. And the first one is very low workability. Very low. The workability is very low. The usage is, we will use this road work. Road work. Okay. And generally road work. Slump value, no. Compacting factor value 0.75 to 0.8. And the BB time is 20 to 10 seconds. So that's the first one. First one. Second one is low. The workability is low. We will use this is mass concreting. Mass concreting. Mass concreting. Shallow section. Low reinforcement sections. There we will use for low workability. And our low workability is equal to, we will get 25 to 75 mm. This is 0.8 to 0.85 mm. Sorry, this is the value. This is 10 to 5 seconds. And the next one is medium. It's a medium workability. Medium workability. It is used in heavily reinforced section. Heavily reinforced section. Next one is concreting with a concrete pump. With a concrete pump. Concreting with a concrete pump. That is 50 to 100 mm. 0.85 to 0.92. Okay. And this is 5 to 2 seconds. The last one is high. Okay, high. This we will use for piling work. Okay, for a piling work, This is 100 to 150 mm slump, and this is 0.92 and above, and above, and there is no VB time. And the last one is, this is the before last, and this is the last. Very high, very high. This is used for trying pipe concreting. Trying pipe concreting, and this value no, and this value yes, 0.92 and above, and this also. So this is the thing. And what we understand from this is, 1 minute. What we understand here is, first point, slump test cannot used for very low workability, very low and very high workability. Very low and very high workability we can't use. Okay, see, very low workability there is no slump, very high workability there is no slump. And the next one is VB test. VB time, that is VB test. VB test cannot be used for very, that is very high and high workability, very high and high workability. And the last one, compacting factor test. Compacting factor test can be used for all type of workability. This is the important data, very very important for your examination. Okay, this is important. This is about the workability. Okay, the test on fresh concrete. Now sixth one, test on hardened concrete. What are the tests that we are having on a hardened concrete? Okay, the test on hardened concrete is, the first one is destructive testing. Destructive testing. And what are the tests we are having? The destructive testing, one is a load test, another one is core cutter test. Core cutter test. Okay, this is used in precast construction. It is used in the precast construction. This is used in road construction. It is used in road construction, but it is used in the precast construction. Destructive testing means during the test we will break the material and to find the strength. Okay, in the destructive we will break the material. We will break the material in order to find the test, in order to find the strength. The second one is non-destructive. Non-destructive test. So in this case, we will not break the material to understand the strength. In that, first one is a rebound hammer test. Rebound hammer test. And the second one is ultrasonic pulse velocity method. Ultrasonic pulse velocity test. And the rebound hammer test, which is this test is the important point. Okay, here it gives strength of surface concrete. Okay, so this test is not that much reliable. Here the point is important. Okay, so the rebound hammer test means this is the wall. For example, in that wall we will fix the hammer and give a energy, and the energy which is absorbed by the slab or any member, that will reback to the hammer. Now the hammer will absorb that return back energy. Based on that energy absorbed by this hammer, it will give the strength. Okay, but here the problem is the rebound hammer only, that is approximately, it is give only the surface concrete strength, not inside concrete strength. So it is not, so that it is not reliable. Then ultrasonic pulse velocity method, so actually it is somewhat reliable in nature. It is determined based on time taken by ultrasonic waves, to travel through concrete is measured. So the time taken to travel the ultrasonic wave within the concrete is measured. Now the time is less. Here the point is time is less than good concrete. Then good concrete means, the good concrete means denser concrete. Okay, and vice versa. The last one is, it is used for detect cracking. It is used for detect cracking also. So these all are the important point. Just keep in your mind. Okay, they will ask you the match the following: destructive testing methods, load test, core cutter. Non destructive, rebound hammer, ultrasonic pulse velocity method. Okay, now the seventh one, mixed design procedure. I will give the step-by-step procedure, but the mixed design is very big thing. Okay, you don't want to study everything, but this mixed design procedure, they will ask in the statement question, the ESE or GATE, but in the state board level examination they won't ask. But anyhow, what they will ask, arrange the steps. This is the question, arrange the steps. They will give the 4 statements and they will ask you arrange the steps according to the procedure, mixed design. The first one is find the, it's the first step, find the target mean strength. find the target mean strength. Second one is find water cement ratio corresponding target mean strength. Next one is find water. Fourth one is find cement, and fifth one is find coarse and fine aggregates. Okay, this is the actual mixed design procedure. In your examination, they will ask you arrange the steps. This is the question. The design procedure they will ask in the ESC subject type questions. Okay, but that is not required. Okay, the short note, this is enough to clear any state government examinations. Okay, and the last one is, that is the eighth one. The last topic today, exposure condition. Exposure conditions. Very important examination, gate examination and all state government examination question is exposure condition. Okay, you just keep this in your mind. First one, and this is a table. Okay, exposure condition, exposure condition, then the description, minimum grade of concrete, minimum nominal cover, minimum grade of concrete, minimum nominal cover, minimum cement content, maximum water cement ratio, okay. So this you have to study at least 4 to 5 times, then only this will be in your mind. So there is no way, you have to study this repeatedly, read repeatedly. Okay, the final thing, okay. Description, the first one is a mild, okay. First one is a mild. The description is protected. If you want to protect from rainfall, only simply rainfall. If you want to protect only from rainfall, then what is what? Next one is a moderate. Moderate exposure condition. This is exposed to normal rainfall, exposed to normal rainfall, exposed to normal rainfall. Next one is permanently submerged in normal water. Permanently submerged, permanently submerged in normal water. In normal water. This is the case of moderate. And the third one is severe. Severe in the coastal area. Coastal area. Next one is alternate wetting and drying in normal water. And drying in normal, alternate wetting and drying in normal water. Then permanently submerged in, permanently submerged in, permanently submerged in sea water. And a foundation in non-aggressive soil. Foundation in non-aggressive soil. Okay, so this you have to keep in your mind. Read at least 4 to 5 times, then only these things will be in your mind. Okay, again I'm saying severe, then very severe. The very severe, that structure subjected to, structure is subjected to sea spray. Sea spray and alternate wetting and drying, alternate wetting and drying in sea water, in sea water. And foundation in aggressive soil, and foundation in aggressive soil. And the last one is aggressive soil. Okay, and the last one is AGG, aggressive soil. Last one is extreme condition. Extreme condition, it is tidal zone, tidal zone subjected to, subjected to aggressive chemical. Aggressive chemicals. Okay, and this we will use M20 concrete, M25 concrete, M30 concrete, M35 concrete, M40 concrete. And this minimum cover is 20 mm. This is 30 mm. This is 45 mm. This is 50 mm. This is 75 mm. And this one is 300 kilogram per meter cube minimum cement content. Next one is also 300 kilogram per meter cube. This is meter cube. Okay, meter cube. Next one is 320 kilogram per meter cube, 340 kilogram per meter cube, 360 kilogram per meter cube, This is 0.55 water cement ratio, 0.5 reduce 0.5, okay, this is 1.045, 0. This is also 4. This is 0.40. So this is the codal value. You have to read 5 times minimum and maximum infinite times. Read it, you will get the exposure condition. So from that also you can expect a question. For all data and the exposure condition description, everything is very important. Read it this. Okay, so with that we finish in the RCC, the short note under concrete technology. And next class we will see the remaining working stress method, limit state method, so on and so forth. Okay, the start notes will continue. Okay, so thank you for everyone.